when it goes. And then there's like 2 weeks of spring, and then it's summer. Because things grow so quickly. So it gets warm, and then you got those really long days. I mean, everything's like, okay, I got to grow, I got to reproduce, and then I could die. It's all gonna happen.
Yeah, it can get pretty hot there. Been a few different times of the year, like spring, August, and then I've never been there in the dead of winter, so I'm not sure how cold it really gets. But
very cold.
Yeah.
But actually, it's very, it can be very nice because it's really clear, sunny, dry. I mean, it's a bit drier than Calgary, I guess, maybe. I don't know.
They're about on par. Edmonton definitely gets colder though.
Yeah.
Or it stays colder longer.
Yeah. It seems like you get these big high pressure regions, but it's just beautifully clear. I mean, you just have to like wear sunglasses all the time. And boy, that's good for an extra 20 degrees when it's sunny and dry, you know, compared to Vancouver. So, and easier, I think, to keep warm too. Put on an extra layer. You just don't have that penetrating humidity.
Yeah, which is actually nice. It can be hot without making you want to die.
Yeah.
I guess I'm going to start going.
Yeah, sounds good.
So today's meeting today. And the meeting, I guess. I guess I would start by saying that Sagi and I have started about 2 months ago, right? We started talking about polishing, I guess, the 1D codes, right? And the idea came because we're kind of a very interesting time right now, is that we have a 6 to 8 months window where we have the attention of industry sponsors. Most of us are involved in GIFtools, the GIFtools project, where we have to finish, in case you didn't know, we have to finish it by the end of this year. And at the same time, we're all programmers, we're all developers for the simPEG library. So we kind of have this like nice window where we have the chance to be able to tease the attention of these people, right? There's like a handful of users, but they are users that have needs, constant needs, and they have research budgets. Currently, industry is doing really well. The reuse version funds are increasing. So it looks like the next year is going to be a pretty good year for everybody. So the timing is kind of good everywhere, right? We've been really good at simPEG, at like pushing the code and like developing new tools and like pushing the inversions in all fronts. But we haven't spent much time on the user, on the end user part of it, right? So right now we're publishing everything in terms of scripts, in terms of notebooks, which is good for other programmers. But like for industry, they're likely not going to dive in, right? And it's kind of a catch-22. Like we don't really have time to develop the end user part. But at the same time, it's needed because if nobody's using the code, then it's kind of a waste of time. Like, why are we writing simPEG in the long run if nobody's using it? So we want to have as much exposure as possible. So the idea here is that it would make total sense if we can just connect the GUI interface that we have a handful of users are using to be able to leverage this effort of like making inversion easier. Just connected with the open source part of it. It makes sense because then on the simPEG side, we don't need to worry about visualizing and handling files and conversion and all that stuff. And on the GIFtools side, we don't need to worry about licensing or whatever because it's all open source. We just connect each other and then people can try it and run it. So this is kind of like the first stab at it. It's like, how do we connect the MATLAB Java environment to simPEG so that we can send jobs. On our side, we can like develop new codes or like experiment on new things and just give the other end access to our customers, or like, not customers, but geoscientists who do not want to code, they just want to be able to use it. That's kind of what we do. So here's the first stab at it, and I guess I will show this, and what I would like to be able to talk about with you guys is how we ease that connection between the MATLAB and the Python environment. Because right now it's a lot of scripting, but we've talked about it before, right? Be able to do anything through JSON files or whatnot, so I think it would be a good time to revive that conversation. So I will just show you what's happening right now under the hood. Okay, so you guys are all familiar with this. Maybe there's people who will watch it later that are not familiar with GIFtools, but basically GIFtools is it's a fairly simple interface. It's built currently in Java, and it has drop-down menus to be able to do operations like import data, create meshes, create inversions, or whatnot, right? And currently this is like 100% built towards running UBC codes with all the Fortran executables. But because we built simPEG like with such similar language that UBC is used to in terms of like inversion methodology and everything, the connection is fairly straightforward to be able to, instead of sending a job to the Fortran code, to just send it to the Python code. So in the GIFtools world, let's say we have a 1D inversion, so we'll focus on the 1D because Sagi and I have pushed it recently. But obviously we could do this for any of the other inversion codes, right? The idea is that in GIFtools we have an inversion object which knows about meshes, it knows about data, where we can select which data, with mesh topography and all that stuff, and inversion parameters, which were used also in simPEG. Once this object is created, usually the way to go is that you just run the job with the UBC codes, right? So it just goes and calls a Fortran, runs it in the background, returns the result, then we store it inside here. All I've done so far is just add the option that we can run the simPEG code and stuff. Okay, so people will click on this, and what's happening in the background is that it calls Python from the outside and currently just builds an inversion script. Right, so this is just creating the survey like we're usually doing in the notebooks, creating the survey, the problem, regularization, and just exchange all the parameters that we set in GIFtools, just send them to the simPEG, and then run it. What's the run here?
166.
Can you make it bigger, Dom?
Absolutely. Okay, so run the inversion here. We're saving everything in directives. Sorry, this one here. All right, saving all the outputs. And currently this is just written in a MATLAB file format, the .mat, which is a structured array. So we can send back anything. We can send out the models, the finance, 5Ds, all the things we need to plot to do our decay curves, predicted data, right? And then on the MATLAB grabs it. I have just like a small script in MATLAB that once this is run, it just loads this guy back in and then reformat it for GIFtools to be able to digest it. So at the end of the day, once the inversion is done, all the models are loaded. And then we have the same functionality that GIFtools has, where we can visualize the model. Right, we can visualize what simPEG did. We can visualize our predicted data. Same as usual. Normalize method. Oops. Okay, same as usual. Visuals. All that. And then we can also look at our decay curves, same as usual. Okay, so we've connected all the functionality that the users already used to see in GIFtools to just do it through the simPEG code.
One minor comment,
Yeah.
it's probably worth looking into instead of saving it as a .mat, saving it as HDF5. It's a bit more stable and like it'll be easier to introspect if something goes wrong. because it is like
Okay.
very language.
This is exactly the conversation that Matthew we're having. So H5 would be a better format.
Yeah, because then it's very easy to load it back into Python and figure out what's going on. And if MATLAB ever changes how things are saved, like NumPy and the pickle, we sort of found that between Python 2 and Python 3, there are a few changes, and so they made it backwards compatible, but it was a little bit of a headache, whereas HDF5 is stable. Yeah, so that would be easy way to go.
Okay.
And then too, if somebody wants to look at it with different software, that's an easy thing to standardize on.
Perfect. Great. Yeah.
Was there not a big effort to kind of transfer things over to HDF5? Isn't that what Chris was doing?
Yeah, the issue currently though is that when Chris wrote the HDF5 file format, he did not structure it, so it's just stored as a stack of objects with names, like random names that H5 are giving to the item. So it's really hard to query from the outside.
Oh,
It's a container, but it's not really easy queryable database. Just because you just wanted to store. You didn't think deeper, saying like, okay, what if someone wants to interact with it from the outside of GIFtools?
okay.
So GIFtools know how to read and write from its H5, but it's not structured in an easy way that you can just query, like you mean all the items, the data items, whatever.
I see. So that's to accomplish that. That would be kind of like a wholesale rewrite of a lot of things then within GIFtools to make
Well,
sure.
someone would have to review the H5 storage, which is not going to happen anyway because since GIFtools is moving on, there's going to be a GeoH5 now, this the storing device, which are structured.
Oh, okay.
So I don't get this point in time. It's worth our efforts to reformat it.
Yeah, in this case, I don't think we don't need a fancy H5 database for this. Like all we're trying to do is store a dictionary. So either JSON or H5, just like capturing the dictionary, that's all that we need to do.
Okay, that being said, though, is that currently, like we've done a better job at passing stuff between MATLAB and Python because now we don't need to write ASCII files, we can just pass it as binaries, right? So we're writing out the math file from MATLAB that Python reads. Is there a better way to do it? Is there a better way to send stuff across? It's pretty fast to write a math file, but
So I guess I don't understand necessarily the communication piece and how much back and forth is needed.
and show you that on the MATLAB side, it's not complicated. One sec, yeah, bear with me. Not doing this. I think we could. Okay, well, we don't need to look at too much, but currently it's just grabbing all the objects, all the data that it needs.
Yeah.
Okay. Like those are just all vectors and matrices of data.
Yeah.
Creating a math file here. So it's just storing everything in a math file that Python has an API to be able to read.
Okay. Can you store it as JSON? Because that, in terms of like deserializing, because the way we're moving with simPEG is we should actually be able to like create, the simulation object or an inversion object, serialize that, which then saves all of the parameters that you need to recreate the thing.
Yeah.
So in this case, what you're effectively doing, and like this is sort of looking forward, but is setting up an easy way for a user to just generate that like set of parameters, basically. Like the set of JSON, well, it's a dictionary. So your set of dictionary parameters. And so then all we need to do on the simPEG end is it should be as simple as just deserializing that to create all of the objects then that you need.
Yes, I agree. We need to pass data though.
Yeah, okay. So this is where like JSON or HDF5, I think, is a much better way than dealing with .mat files.
Okay, so we could pass stuff around both ways in H5. That's what you're.
Yeah. Because I think like in terms of simPEG, it's immediately very reasonable for us to implement an HDF5 saver and loader.
Yeah.
And that benefits like both GIFtools as well as somebody who just wants to use only simPEG and Python, right? Because for me, I mean, if I generate an inversion basically that's ready to go on my laptop, but I don't necessarily want to run it there. I want to ship it over to the cluster. Like doing that in HDF5 is a very easy and stable way to do that. Whereas writing to like .mat and sort of creating all that functionality doesn't make sense in that workflow.
Absolutely. That makes a lot of sense. Okay. Yeah. And then within the H5, then we can have our dictionary to like rebuild the inversion object on the simPEG side.
Yeah, and so how that will happen, and this is something that we can sketch out, and I think the simulation refactors can help clarify that. But basically what we're doing as we write things with properties is we're creating, like, in a sense, a schema of how to interact with simPEG. So like set your frequencies and all of these kinds of things. What are the keywords, and then how are things nested? And so basically once we have that structure right, you don't need to know about the inner workings of simPEG. We just need to know how to get stuff in and out of that structure. Mm-hmm. And so that structure will then define the data structure of like an HDF5 or JSON file.
So how far are we, like, so I think I'm sort of getting the simulation part will be like fairly close, I guess.
Yeah.
But the inversion, like how far are we? Like I don't have like a kind of clear idea how we're going to serialize inversion part, because like it's a multiple object, and then you got multiple pieces, and yeah, so that's something that I'm not sure going.
So in that case, what you like, all that we need is that all of the pieces serialize. So let's take the simulation, for example. Right now, the simulation, you need a mesh for any of the PDE simulations, right? And so the mesh is actually a distinct object, because it serializes, we can then just serialize it when we serialize the simulation, right? There's all the instructions all the way down the like dependency path are serializable. So that is then what we need to implement on the inversion side as well. Is then looking at all of our directives at, I think the optimization or the objective function stuff is really close, if not there, basically already. Yeah. But then once we have like directives, the optimization serializing, and the objective function stuff serializing, that then basically means you can serialize the inversion object, right?
Is it possible, like there are multiple properties, for instance, and like we're not using all of them, for instance, but my guess at the moment, like we're serializing everything.
So what we need to be careful with, and this is something I'm trying to do, and this is why, like, I sent that over. Well, when I've been looking at the simulation stuff, I'm trying to tease apart what needs to be a property and what doesn't. And so there's some cases where properties isn't used and it needs to be injected. There's other cases where properties is being overused. And so what I mean by that is that if there's something that can be generated based on user input data, then it should not be a property. I can show you an example if that's helpful.
Yeah. I got the point. Yeah.
And so here, let me just find this first. So it's this branch.
One minor comment, maybe on the script and drivers. Yeah, I would like that would be nice at the very beginning. You set the random seed, so you will ensure that the result will always be the same if you run the code. Because, for example, I see that you're using the beta estimate, which is a random process. So have like each driver beginning with a random seed, we make sure that so it's always consistent.
And that's something that we should be sure to set within simPEG, so that it is easy to set a random seed and serialize that as well.
That's a keyword.
Yeah.
We were talking about this last week.
I think we fixed it at the moment, right? We have fixed that.
Well, in specific examples, but we don't have it like serializing, for example. So that would change. Because if you ran the whole inversion and didn't save your random seed, then we wouldn't know, unless you were recreating from a script.
So we can elaborate on the random seed?
Yeah.
So right now, if like in most of our examples in simPEG, we set a random seed.
I mean, is this for noise or is this for something else?
No, so the beta estimator, for example, uses a random seed to create a random vector, which we hit against both the JVec as well as your regularization.
Okay.
So that requires a random vector. or
Yeah.
something.
But they use this.
But the random seeds are always for generating some kind of a random vector so that you make sure that you've got a reproducible array. Is that
Right. Well,
Yeah.
so when you set a random seed, what that then means is like we have picked a specific random vector that will always work.
Yeah. Right.
But right now, unless that is in your script, we don't actually save the seed anymore.
I see. Okay.
So we don't know.
So your results are always different.
Yeah.
Yeah.
Yeah, it's kind of annoying. Like even your different machines that have a little bit different
Yeah.
version, sort of, because like numerics are a little bit different. So I don't know. I think that's it's not very different. I think that's okay, but it's not exactly the same. So it's not quite reproducible. So you can set like everything really same. That might be a little bit better.
Dom, can you log onto my screen for a sec?
Well, it's actually very important if you're, especially when you're testing with, say a few data, as in, frequency domain EM, right? And then if you start off with, adding errors and you're having a different random seed, I mean, you actually can get quite different errors and the results can really be quite different.
Oh, so we're not doing for the errors, I think.
No, but for whatever, right? But
Yeah,
I mean, you might well do it for the errors. Okay, so if you're locking in, like you're trying to do a Jupyter notebook or something, or present anything that's reproducible, then you want to add random noise, but the random noise is the same in every instance, right? So that, yeah,
Yeah.
just eases things.
Yeah.
That's a really good point, and that's something that we could easily implement in the synthetic data object is a random seed, so that you always, like, once that object's created, the seed is the same. Yeah. Yeah, and that could be something that the user could input as well. So this is just one example that is, and this is like not a knock on anybody's coding. Like it makes perfect sense, but this is an example when we're thinking about serializing of redundant information that we don't need serialized. So in this case, when we create a survey, the source list will be a property. And so I can't remember if that's done yet or not, but it will be. So the source list is a property and it contains all of its locations, and then each source has its receiver list. So in that case, all of the information about the electrode locations is actually contained in the source list and the receiver list.
Not in the problem level.
Right, and so in this case, if we were to serialize this object, that information is redundant, right? The A locations, B locations, M and N. All of that is completely redundant because it's already contained in the source and receiver list. So then in that case, what we want to do, and I'll show you sort of what it's looking like when I maybe I haven't done it yet. But then in this case, like all that we would need to do is instead of these being properties, they are then just app properties.
Yeah, and then
Which is a
And
Python.
yeah, and then they are computed, and they can be stored like lazy loading, like what we always do.
Right.
But it's just sort of recognizing that they don't need to be serialized.
But let's say it's let's say that right. So no, I think the lazy loading we could do that. Then that's fine.
Yeah, because so what I was implementing, and I forget which branch this was on, but basically then you do a
Yeah.
like def a location, and then if
They already stored.
well if it's not there, then you get the AMN
Yeah.
locations,
That's
and then
generally
so yeah, so that's like one simple way to do that.
Okay.
But there's other cases where, for instance, like a transmitter types, for instance, then we're using, so let's say I'm using vertical magnetic dipole, although I have a lot of other options, then that's a property needs to be stored.
Well, that is based on the class, right? So when we serialize
Oh, I see.
something,
So that's actually fine.
that information is communicated.
Okay.
Because it is a distinct class. Maybe I can show you. I don't know if that's helpful.
And you just use like the isInstance command to figure out what kind of class it is and kind of.
You don't actually even need to do that. It's basically set up under the hood. So it is like the class name is serialized, and as long as we have the instructions of like where the class is, it can be immediately recreated. So you don't necessarily, you shouldn't have to go through and do the searching.
So there'll be something like that app property thing that just those properties that you were specifying under the app property. It'll just go through and it'll automatically reset that property after you.
Well, it'll set it so like it'll be very similar to the mesh, for example, when you're creating an edge curl, right? So the very basic information that we need to create a tensor mesh is the tensors in each dimension, right? And so when you save the mesh, that's the only information that's going to be saved, like that and your origin, right? So those are the pieces of information we need to recreate it. So then when you recreate it, those are the only things that it knows about. But then because we have the set of instructions attached to the class about how to create the edge curl if it's not there, when you call edge curl, it'll get created. So it's very much just like the way when you initially set up a class, it's going to behave exactly like that.
What's going to happen, like, let's say I put, so problem contains everything now, right? Like I plugged in survey, I plugged in mapping, I plugged in models and everything. So if I serialize that, what's going to happen? Like it's kind of like go all the way down and serialize it, and then put it into one JSON file. Is that what's happening?
That's what's happening. And so if we have problems with space or like if things are very large, we can specify how it serializes. So we may end up wanting to do something a little more clever and like compress data files and things like that. But that can all be taken care of in the same way. So what's kind of nice is like we can basically, as long as we can specify the schema and like what keywords there are that you need to set as a user, then how we compress and store it actually is irrelevant to the
It's
user.
different.
I see.
Yeah.
So it's a separate process. You first generate the JSON, then compress it. Is that the idea?
Not necessarily. So like we can provide a set of serializing instructions that do that say like, hey, this thing should be saved as HTF5. Like this thing should be saved as JSON. We can provide all those instructions.
Because the GIF5 is compressed, right?
Yeah.
Yeah. It's a nice solution.
Yeah. Well, and actually, like we can readily serialize to HTF5 or to JSON. Like we can just say save as JSON or save as HTF5. Doesn't matter.
Okay, so you would not do like a crossbreed where you have a JSON file that trigger that knows what H5. You store everything either or.
I mean, we can go in and do both if there's
But
reason
there's
to.
no point.
Out of the box, we have the ability to serialize to JSON and to HTF5, like serialize the thing. If there becomes reason to sort of do a hybrid, we can do
I
that.
guess there's more
but-
reason.
Yeah.
If everything's like, save it as a JSON, just a text file.
Yeah, yeah.
If it's heavy, then throw it in the compress HTML
Yeah.
file.
And to like, with respect to data files and things like that,
Yeah.
we don't necessarily have to resave like a simPEG data file. We can be smart about that in the sense that like, as long as we know, for example, it is in like our EM data in this GeoSci like XYZ file, and we know we should be using this parser, like we serialize those instructions to say, look at this file, use this function, that gives you my data. So that's sort of like down the road. Right now, we probably will have to copy it because that's just easier, but.
And it's way faster too.
But those types of things, because especially if you start getting to very large data sets, we certainly don't want to be generating copies. So that's, yeah, those are all things that are doable.
Okay, that's great.
So, because I can show like the, actually, that might not be in Word. So here, for example, when I serialize my simulation, I have my mesh generator, and then you can see that that's another dictionary. So that's actually a whole other object that has been serialized underneath. And then unfortunately we don't see it wrapped. But this is all that it looks like, right? It's basically just a dictionary.
Yeah, but that's why it gets heavy, right? If you start dealing with, you don't want to have to write to file. Yeah.
Right.
Long decimal places, because that's going to be a killer.
Right, and then in this case, like some of the things that I've been playing around with and don't necessarily have it figured out yet. Well, I've got a first pass, but like of how to point. Like this can either be an array or it can be a pointer to a file. And so that is working in some cases. So.
But like, can I just store that as a HD file?
Yeah.
So, okay, so that's a two-path. Like I choose JSON. If I choose HD file, that will be a structured kind of array.
Yeah.
Okay.
So I think that's
great.
all you need.
After the meeting, if you can point me to where, how this is called and everything.
Sure.
We're still just need them to write the HDF file on the MATLAB side to take it and output it.
Yeah. Yeah. Well, and right now, I mean, like you can work exactly with the same dictionary that you've structured, if those are the set of parameters that you need.
It's first pass, so we can do whatever we want.
Okay.
Yeah. Well, we have a function for HD file, like a saving dictionary to HD file.
On the MATLAB side, you mean?
I don't know.
Okay.
There should be something built into MATLAB that lets you save to HDF5.
Yeah, well, Chris had to write a bunch of stuff, so I'll have to dive into it, but
I'm not sure. Maybe like the math file could be already, I guess. Not sure, but need to double check.
Is that also because GIFtools depends on the older version of MATLAB than the?
I don't know. Not sure. Yeah, we just need to check.
Yeah.
No, not sure.
Pretty straightforward to output this stuff and then run it on a cluster somewhere else?
Yeah. Yeah.
It's like already implemented it right on simPEG. Yeah. So now.
Oh, so you just, you can call the simPEG that does it for you.
Yeah.
And you don't have to write anything for, okay, cool.
Yeah. Again, so that's one of the things I did with this casing repo too, is like wrote a driver that just takes the serialized objects as inputs and then runs the simulation. So like my,
right, and that's why you basically had a driver or something similar to that for each.
Yeah. So like this is actually all that I needed to run the simulation. So this is getting closer to how we actually want to work with this. All of the stuff below was for a 2D, but this is all that I needed. So ideally that should be like how we should be able to serialize and run. This is a forward simulation, but we should be able to do the same thing with it.
Okay, so you packaged it all into your time domain simulation, I guess, supplies.
Yeah.
That's what I'm wondering right now is that where are those drivers should be living, right? Because we could either store it on the simPEG side or the GIFtools side. But,
So what this, there's a number of things I really don't like about this right now because it's a weird extra layer of simPEG, but like I was sort of using it to think through what the simulation should look like. So it's sort of like these weird classes strapped onto simPEG to create the way that I wanted to interact with it. And so ideally, this actually should just be how we run a time domain simulation. So this should be core simPEG.
Okay.
One of the things I would like to look into too, and this was something I would appreciate your guys' opinions on, is when you're sending stuff like to clusters, setting up a job, are you writing, like you're writing a Python script and then you're calling Python?
I've only done it that way.
Okay.
That's how I've done it. Like, yeah, that's one.
Okay. Because what I think would be nice to do is to be able to call simPEG like from the command line. And so what I mean by that, this is a package I was reviewing for JAWS, which is kind of cool.
Instead of doing Python space run this, you run straight from that line.
Yeah. So here. So what he's done is created like a structured YAML file that then you can just run on the command line. So in this case, what we would be doing is creating the structured JSON file. So like this is how they're calling their Python code is just like, the package name simulate this. And so it would be really kind of cool, and this is interesting to see if we have like simPEG simulate and then your simulation file, or simPEG inversion file.
Okay.
A bit like the UVC code.
Yeah, just to have that command line option, like would that ease things from?
I don't think it would change anything. But,
Okay.
Yeah.
But that's what's happening is that they're installing everything here.
No, I mean, it would already have to be installed. Like you still have to have the right environment. It's just you're not directly calling Python run this script.
It might be advantages though, because the way the system interacts with the code is different. If it's a Python instance that's running in the background rather than its own program running, I think there might be some advantages of running it this way.
And the other thing that I think could be nice too is that if we do change like simple things in the API, we could sort of do all those changes self-consistently. Whereas right now, if we change something in the API, you then need to update your GIFtools, the mechanism with which it writes the script. Does that make sense? So like if we change, I don't know, something to PEP8, so NC. If we change from NC to number of cells, you then potentially have to go in and change that when you write your script, how things are assigned. But as long as we remain consistent in how the file is written out, you would only then need to change it in one place, which is writing out the file, rather than in both writing out the file and generating the script.
I see.
Does that make sense?
Yeah. How, can you show me what's that YAML file just look like?
Yeah, it's pretty simple. So it is like just their parameters, basically.
Oh, I see.
So it is effectively a dictionary. YAML is meant to be like a little more human writable. For us, I think JSON is better because there's more information that we need to inject than this. Like you don't want to be going in and trying to manually enter time steps and stuff like that.
Mhm.
So
Yeah.
yeah, so something like that is worth thinking about, and just like as you're writing, like see if that is something that makes sense. Because I don't necessarily know how to do it like offhand, but I don't think it's a hard thing to do as long as we get the objects right. Like that's the biggest thing.
Diane?
Oh, hi, Diane. Come on in.
Nice.
So H for, I guess, in the short time.
HTML5.
Shift 5 for JSON.
On Python side, we'll
Have a chair.
just need to figure out in the mouth that short.
No, that's okay. We might need to write a little bit more, but and then the other thing is that the drivers we can sit in on the simPEG side.
Yeah, it would be like good to have that mentioned one-day hackathon for simulation. It might be good. I'm not sure when you could do it, but I think it would be good to know what that many things to be changed.
Yeah.
How, because map out like, okay, this is a simulation class, and then it's how I want to serialize it.
Yeah.
Kind of like showing that will be, I don't know how that's going to happen. So
Yeah, I don't think it's too far out. I need a chunk of time beforehand just to make sure that we can use our day well. But yeah, we can try and do that in the coming weeks.
Just back to the drivers.
Yeah.
Do you want to sit them? You want them to like have like a list of drivers, or you want each problem to have its own driver? At what level do you see it?
I guess like the simulation should get rid of drivers, if that makes sense.
No, but the part that will take on the JSON and then recreate itself, recreate a simulation. Like there's a layer on top right there.
No, so the simulation object should recreate itself. Like, so you still need to like set up the correct namespace. So I guess right now I would say continue writing scripts that interact with simPEG. That's a good way to go for now.
Okay.
The driver files, like when we create, I guess like the idea should be that it should be no harder than if you have a simulation created and we know which model we want to input. You serialize all of those things. It should be no more than 2 lines of like deserialize this object and then run the thing with the model. So that those steps should be on the simPEG side, but for now it makes sense that you're doing it on the GIFtools side.
Okay. I think I understand, yeah.
So like we're trying to, I guess, bring these things closer together, but right now, because there's still development that needs to happen on simPEG, like as long as that sort of interface is fairly clean with how you're writing out the script,
Yes.
then there won't be any problem to like transition that later on.
I'm not fully understanding the inner mechanics, but yeah, we'll do that.
Yeah. Yeah, because like I think we want to be able to do like this, right? I mean, that should be all that you need to do on the GIFtools side to run a simPEG inversion.
Okay, that's great. But where is this script living? You know, so let's say you're an end user and I give you a JSON file and I say just run it.
Yeah.
How is it going to be called?
Oh, that's fair.
Yeah.
That should be on the GIFtools side.
GIFtools side.
Yeah, yeah. So because like the simPEG should be able to generate all of these things and intake them.
Yes.
But actually like the .run button, that should be on the GIFtools side.
Yes, because you want to wait for the result and all that stuff, so that's right.
Yeah,
Okay.
yeah. So GIFtools generates all of these pieces that you need.
Yeah.
simPEG knows how to ingest those.
Yeah.
And then when you say .run, like GIFtools triggers the simPEG.
Cutting the result. And all
Yeah,
that stuff. Yeah,
yeah.
that's right. Yeah, that makes sense. Perfect. I'm happy with that conversation. So we'll keep working on it.
Cool.
Good.
Yeah.